Just wait. Yes, students, I have shared one notice on your group regarding the National Voters Day celebration. There are different types of competitions, different type of competitions we have organized, like allocation competition, then quiz competition, allocation competition, quiz competition, then poem reading competition. If anybody interested from your class, please give me the names. Those who are interested for different activity like essay writing competition is also there. Then debate competition. I already shared the notice on your group. Please give the nominations from your class, those who are interested to participate in this National Voters Day celebration. All the events are going to be held through online mode only. Now in Physical Pharmaceutics 1, we have discussed about the different chapters which include in Physical Pharmaceutics 1 like surface tension and interfacial tension, states of matter, then solubility, then complexation and pH buffer isotonicity part. Okay. Now in Physical Pharmaceutics 2nd, same pattern is there. For Physical Pharmaceutics, 10 marks internal assessment, 5 marks continuous mode, 15 marks exam for practical, and for theory same 25 marks internal, then 75 marks end semester examination, and here again 10 marks for the continuous assessment mode. This is the pattern for Physical Pharmaceutics 2. In for Physical Pharmaceutics 1, in Physical Pharmaceutics 1, we already discussed about solubility of the drug, then states of matter and properties of the drug, and different physicochemical properties for the drug molecules, and surface tension and interfacial tension, complexation and protein binding, and in last unit number 5, the pH buffers and tonic solutions part. We have already discussed this part, and in Physical Pharmaceutics 2, we are going to discussion on the different types of the properties, physicochemical properties, the remaining properties like size, shape, and surface area of the particles, then volume of the particle, how the volume of the particle is going to be determined by using the different methods or different techniques which is used for determination of the size and shape of the particles. And In next minute, colloids we are going to discussing here. Colloids, then different type of the colloidal system, like coarse dispersion as well as colloidal dispersion. Coarse dispersion and colloidal dispersion part. And after the course discussion and colloidal discussion, the next point is the see here one by one we'll discuss here the first unit. Why this physical pharmaceutics it is important? What is the scope of this subject? This course deals with the various physical and physicochemical properties and principles involved in the dosage forms, oblique formulations. Theory and practical components of the subject help to the students and to get better insight into the various areas of formulation and research development and stability studies of the pharmaceutical dosage forms. So we already discussed during the first lecture of the physical pharmaceutics 1. And what are the objectives of this physicochemical, this physical pharmaceutics 2? After completion of the course, the student shall be able to understand the various physicochemical properties of the drug molecule in the designing dosage forms, to know the principles of kinetics and use them for the stability testing and determination of expiry date of the formulations, to demonstrate use of physicochemical properties in the formulation development and evaluation of the dosage forms. And what are the contents which involved in this physical pharmaceutics 2? The first chapter is the colloidal dispersion. First chapter is the colloidal dispersion. Now in colloidal dispersion, we are going to discussion on what do you mean by colloidal dispersion. What do you mean by colloids? Colloids actually it is a Greek words. Then colloids means glue-like substance. Glue-like substance are called as colloids. Okay, and the size ranges between 10 to 100 micrometer in size range. Micrometer size range for the particles. And afterwards, there are different type of this dispersed system. One phase is going to be dispersed into the another one. It is called as a dispersion type of dispersed system. Okay. Now in dispersion system, also we are going to discussion on the different type of the dispersed phase and dispersion medium. Okay. The classification which is based on dispersed phase and dispersion medium, the classification which is based on size of the particles, whether it is a coarse type of the dispersion or colloidal type of the dispersion. Then the different general characteristics for the colloidal dispersions. Yes, students, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Then
Yes, sir.
the size and shape of the colloidal particles, different size range for the colloidal particles we are going to discussing here, and we are going to analyze the size and shape of the colloidal particles. Then the classification of colloids. Colloids are lyophilic, lyophobic colloids. We are going to discussing here, or association type of the colloids. Colloids are going to be classified into three types. One is the lyophilic, lyophobic, and association type of the colloids molecules. And their comparative properties or the comparative account of general properties for the colloidal dispersion. Then afterwards, we are going to discussing here the different types of properties, the different type of properties for the colloidal particles, whether it is a optical properties. Optical properties depend on the optical properties. We are going to discussing here the different type of properties like Tyndall effect, how the light rays which is passes from the colloidal dispersion, and what type of the mechanism which is takes place, and that is observed by using the different type of the microscopes which is used, like electron microscope, ultra microscope, or light scattering microscopes are used. There are different type of optical properties, like first one is the Tyndall effect. second one is the electron microscope, third one is the ultra microscope, and light scattering phenomena, which is determined by using these optical properties. Then next property, it is called as a kinetic type of the properties, depend on the motion or depend on the kinetic properties we are going to evaluating here, depending on the speed or depending on the motions of the particles. Like the first one, it is called as Brownian motion. Brownian motion of the particles. Brownian motion of the particles means what? The colloidal particles are continuously collision between the colloidal particles and molecules of the dispersion medium into the Brownian motion or zigzag motion of the particles we are going to be observed here. The next method is called as diffusion. How the molecules, how the colloidal molecules are going to be diffused from a region of high concentration site to the low concentration site. And there are different equations are there, like Noise-Whitney equation for the diffusion, then fixed first law, then modified fixed first law for the drug diffusion. That part we are going to discussing in this diffusion points. Then again, the next kinetic property is the optical properties for the drug molecules. In optical properties, we are going to evaluate the osmotic pressure osmotic pressure of the particles. Osmotic pressure, with the help of osmotic pressure, it is also possible to determine its molecular weight for the particles. The next one is the sediment properties. We are going to evaluating here the rate of sedimentation, which is based on the Stokes law. We are going to determine here. And the next property, next kinetic property is the viscosity. Viscosity is the resistance to flow of the fluid under applied stress. It is the viscosity. Viscosity is also going to be determined in these kinetic properties. And then next point, it is called as an electrical properties for the drug colloidal particles. In electrical property, particularly, we are going to discussion on the electrophoresis and the electric double layer for the colloidal particles. And in electrical double layer, after the electrical double layer, the next property is called as a donor membrane effect for the colloidal particles. These are the different types of optical, kinetic, and electrical properties for the drug molecules. Then, what is the effect of electrolyte when the small amount of the changes which is takes place into the colloidal dispersion, and what type of the changes which is occur, that part we are going to analyze here. And then the co-acervation method, peptidation method, and protective action of the colloids we are going to evaluating here. In protective action, peptidation action. Suppose if the peptidizing agents you have to add it, then what are the changes which is occur? That part you have to analyze it. And the next point is the protective action. Suppose if the one colloid is going to be protect with the others, when the addition of the lyophilic colloid or lyophobic colloid which is takes place, and that part also we are going to discussion on this protective action of the colloids. This is about the first chapter which is included in your physical pharmaceutics 2, physical pharmaceutics 2. Okay, then the second unit is the rheology, and second unit is the rheology. Once we know the properties, once we know the size, and once we know the shape of the colloidal particles, then we'll move towards the next point, that is called as rheology. Rheo, it is again Greek word. Rheo means to flow, and logos it is called as a science, and then flow science it is called as rheology. Rheology, it is a in rheology it is a branch of physical pharmaceutics and deals with study of the flow of fluid. It is called as the rheology, or rheology, it is a science of the flow of a material. It is called as rheology. Then what type of the materials is going to be followed by the Newtonian law or non-Newtonian law, we are going to discuss here. The Newtonian law or Newtonian fluid and non-Newtonian type of the fluid, which depends on this rheology characteristics of the fluids. One, if it is Newtonian, then the fluid which obey the Newtonian law, and if it is non-Newtonian system, the fluid which does not obey the Newtonian law. That part we are going to discuss here. Afterwards, in Newtonian and non-Newtonian system, uh, also we are going to study the flow of fluid or the different law of flow, whether it is a Newtonian and non-Newtonian system, and its law we are going to discuss here in this rheology point. And afterwards, the different type of the viscosities, whether it is absolute viscosity, then relative viscosity, then specific viscosity, then kinematic viscosity. These all are the different types of viscosity. Okay, viscosity means what? The ability to resistance to flow of fluid, it is called as viscosity. Okay, now here in rheology, which is related to flow of the materials, whether it is in the form of a liquid or whether it is in the form of an solids. Okay, then effect of temperature on this rheology system. What is the effect which is takes place on the flow characteristics of the material? That part we are going to discussing under this rheology concept. Okay, because rheology, it is important for everywhere in the pharmaceutical formulations. For example, if it is solid, then we are going to analyze the rheological behavior of the solid particles, and if it is a liquid, then also we are going to determine its rheological characteristics. Particularly, it is important with respect to the flow of the materials from the container. Okay, and suppose if it is more viscous, then it is unable to flow from the container, then it is very difficult to take the dosage form. That's why here we are going to discussing the rheology concept. Then the non-Newtonian system, again the non-Newtonian system are different. Here examples for the Newtonian system and non-Newtonian system we are also going to discussing here. And in case of a non-Newtonian system, it is divided into three types. One is a pseudoplastic system, then dilatant type of the system, then plastic system, and afterwards the thixotropic, then thixotropic behavior into the formulations and determination of the viscosity. Different types of the methods which is used for determination of viscosity of the liquids, like by using single point viscometers and multiple point viscometers. If it is single point viscometers, then we are using falling sphere viscometer, where the cat viscometers, which is used for determination of the viscosity of the liquid. Why? Because it is a single, because one point determination it is takes place. That's why it is a single point. And in case of a multiple point, we are going to determine the shear rate for the particular substance. We are going to determine here with the help of multiple point method, like type of the point Bob viscometer, cone and plate viscometer, then Serle type of the viscometer or Ferranti Serle type of the viscometers. So many types of the viscometers are available for determination of the flow of fluids. Okay, that part we are going to discussing in this unit, in this chapter. Then afterwards, the next point, it is called as a deformation of the solid part. In deformation of the solid is particularly deformed with respect to the plastic or elastic type of the deformation. Whether it is a plastic behavior or whether it is a elastic behavior, whether the permanent deformation takes place or the temporary type of deformation which is takes place. Yes, students, now here I will give the example. If you have to apply the force on the rubber, if you have to apply the force on the rubber, then what happen? The rubber get stretched out up to certain extent. Okay, and if you have to apply more and more force, then what happen? If you have to apply more and more stress, then at point which the rubber get break it. Okay, that breaking point we are also going to be determining here. The then elastic deformation and plastic deformation of the materials. Then afterwards the Hickel equation for stress and strain, that part also we are going to determine here, and then different type of the elastic modulus we are going to determine in this chapter, or we are going to discussing here in the different types of the modules, uh, different types of the modules which is used for the determination of the flow type of the materials also. Then in elastic and plastic deformation, it is important. Then distinguish features between plastic deformation and elastic deformation. And then Hickel equation is also we are going to determine here the different type of the stress, then different type of the stress and strain we are going to determine here under the banner of this rheology chapter. Then the next unit, third unit, is the coarse dispersion. Coarse dispersion. In coarse dispersion, particularly, we are going to study the suspension. Suspension is a liquid dosage, biphasic liquid dosage form. Then, after the suspension, the different types of the interfacial properties which is suspended into the particles. How the solute particles get suspended into the liquids. The basic mechanism we are going to discussing here under this coarse dispersion chapter. Then settling of the particles into the suspension, how the particles get settled into the container at the bottom of the container, that part we are going to discussing here. Because again there are different factors which affect on the rate of settling of the particles. Basically the size is going to be affect on the rate of settling, density of the particle is also going to be affect on the rate of settling, okay. Then mixing density as well as then afterwards the different type of the suspension, types of suspension we are going to discuss here. In types of suspension, whether it is a flocculated suspension or deflocculated type of the suspensions. Okay, flocculated and deflocculated type of suspension. And then the emulsion part, different type of the emulsion, suspension and emulsion, both are the biphasic liquid dosage form. In case of an suspension, we are going to addition of the solid substance get suspended into the liquids, and in case of an emulsion, the oil is going to be dispersed into the water. Here the solid, it acts as the oil, and the second is also liquid in liquid is the emulsion, and solid in liquid we are going to be added into this suspension. Then the different theories of the emulsification: adsorption theory, interfacial film theory, then electrical double layer theory we are going to discussing here under the banner of this different theories of the emulsification. And afterwards the multiple type of the micro emulsions and multiple emulsions we are going to discuss. Afterwards, the next point is the different types of stability of the emulsions. Since different type of stability of the emulsions, it includes what? The cracking, then creaming, then phase inversion. We are going to discuss here and here in this point, stability of the emulsion. Then last point, we'll move towards the formulation aspects. You have to go for the determination of preservatives, different types of the preservatives which is used in uh, emulsion formulation and suspension emulsion formulation and suspension formulation. Then rheological properties of the emulsions and suspension, you have to determine it. And also here we are going to study the hydrophilic lipophilic balance method. We have to use it for the calculation of the rheological characteristics for the drug molecules. This is about the third unit. It is called as coarse dispersion. And next, after the coarse unit, the next one is the Micromeretics. Yes, students. Now here this chapter is very important for, this is the basic of basic backbone of the pharmaceutics, because science we know the size of the particles, we know the shape of the particles, we also know the number of the particles and volume of the particles. Exactly what is the volume, what is the size, what is the shape, what is the surface area of the particles. It is possible to determine by using this micromeritics techniques. Micro means it is a small, and again meritics, it is called as science. Micro is the small particles and meritics is the science. The science of small particle size, it is called as the micromeritics. Okay. Here particularly we are going to discussing here size of the particles. Okay. The size of the particle is going to be measured in the diameter. Okay. The size of the particle is going to be measured in diameter. Then the different types of the diameter for the particles like surface diameter, volume diameter, surface diameter of the particle, volume diameter, and surface diameter, volume diameter, then wet moment, mean diameter of the particle. Meters, which is for determining of the size range of the particles. And afterwards, the mean volume diameter, mean surface diameter, mean area diameter. These all are the different types of the diameters for the particles. It is possible to determine by using this micromeritics concept. And afterwards, if again again the diameters like Farad diameter, then projected diameter, and Farad diameter, projected diameter, and another one type it is called as the Martin diameter. It is possible to determine here. Martin, Farad, and Martin diameter, Farad projected diameter, we have to determine under this particle size determination. See, all the pharmaceutical powders are not distributed in uniformly because we are getting the polydispersed type of the dispersion. Polydispersion type of the dispersion we are getting here. If we are getting the polydispersed type of the dispersion, then you have to go for the dispersibility index for that particular particles. How the particles are going to be distributed. Then second point is then you have to plot the frequency of the particles. You have to count the frequency of the particles, and once you will get the frequency of the particle, then go for the next point. After the frequency, you have to plot the different type of the graphs like particle number versus the size of the particle. Then it is called as number distribution. The dispersion of the particles with respect to the number, it is called as number distribution. The dispersion of the particle with respect to its weight, it is called as weight distribution of the particles. And the particles, we have to draw the graph by using number of the particles with respect to the frequency of the particles, and that graph it is called as frequency distribution graph. And if you have to convert that frequency into the log frequency with respect to the particle size, then you will get the graph for log distribution graph we are getting. Then according to the data, you have to plot the different types of the graph for its distribution. Okay, there are different type of the distribution of the particles with respect to the number, and the particle distribution with respect to the weight. Afterwards, then after the number distribution and weight distribution of the particles, then you go for determination of particle number. How many number of the particles which is present into the formulations, or total number of particles you have to determine it. Then the next heading is the different methods which is used for determination of the size of the particles. Okay, in different methods which is used for determination of the size of the particles, like what are the particles it is possible to determine here. The first one is the first size of the particle is going to be determined by using sieving method. Then second one is the sedimentation method. Then third one is the optical microscopic method. These are the methods which is used for determination of the size range of the particles. And after the size, you have to go for determination of the shape of the particles. The shape of the particle is also possible to determine. The shape of the particles is also possible to determine by using DCM or to determine the shape of the particles. And the size range also it is possible to determine by using SCM. It is possible to determine the size range of the particles. After the size and shape of the particle, you have to go for determination of its surface area. Surface area of the particle is going to be determined by using air adsorption method and air permeability method. By using air adsorption and air permeability method, it is possible to determine the surface area of the particles. And once you know the surface area, then go for volume of the particle, and volume of the particle is going to be measured by using Coulter counter method, which is used for determination of the volume of the particles. And then go for determination of the surface area by using air permeability method and air adsorption method, which is used for the determination of the surface area of the particles. And afterwards, the next property is called as in fundamental and derived properties of the drug molecules. What are those fundamental properties? Like the first fundamental properties for the particles is number of the particles, then particle size and size distribution, then particle number distribution, then size, shape, number, and volume of the particles. These are called as fundamental properties. And in case of derived properties, we are going to determine the bulk density, then tap density, then bulk density, tap density, then granule density, then specific density, and bulkiness, then porosity, then car compressibility index. All these are the properties which is related to the flow behavior of the drug molecules. And then the packaging arrangement of the particles, how the particles are going to be arranged into the dosage form, whether it is a loosely packed arranged or closely packed arranged particles, whether it is the packing arrangement is in the form of an loosely packed or closely packed or rhombohedral type of the packaging for the particles, you have to evaluate it. And then go for the densities, different type of the densities you have to determine it. In different type of the density, particularly tap density, bulk density, car index, you have to determine it. And then bulkiness, you have to go for determination of bulkiness. Bulkiness is the reciprocal of the density. Then the different flow properties like angle of repose, then flow rate. For the powder particles, you have to evaluate and then compare with the standard results according to the IP. You have to compare it. Then you will get the flow properties for your powders, whether it is in the form of excellent, whether it is in the form of a poor flow, whether it is possible, whether it is very poor flow, or whether it is in the form of an excellent flow properties for the drug molecules. Then the next chapter, it is kinetics and drug stability. In kinetics and drug stability, first we go through the different types of the kinetics properties for the drug molecules. Kinetics means what? It is a motion, or it is a speed, or it is a velocity of the rate for the drug, and that is called as the rate kinetics. Okay, then whether it is in the form of pseudo order, first order, or zero order or second order type of the reactions, and their constants we have to determine here. Here if it is first order, then zero order, then go for particularly determination of zero order self life, zero order first zero order reaction, zero order self life, and zero order half life for that particular kinetics. If it is pseudo order, then also go for the same thing. First order half life, first order self life, second order half life, second order self life, you have to determine it. And then afterwards, here in kinetics only, we are going to discussion on what do you mean by kinetics, what do you mean by rate, what do you mean by order of the reaction. That part we are going to discuss here. Then the different methods which is used for determination of the order of the reaction, whether half-life method it is used, whether the graphical method it is used, or whether it is a substitution method which is used for determination of the rate of the reaction or order of the reaction. Then the different factors which affect on the physicochemical properties, or the different physical and chemical factors that affect on the degradation of the pharmaceutical product, means how the factors is going to affect on the half-life and shelf-life of the drug molecules. That part we are going to discuss in here. What are those factors? First one is the temperature. Temperature is also going to be affect on the temperature is going to be affect on degradation of the product, pharmaceutical product. Then solvent, the nature of the solvent is also going to be affect on this degradation of the product. Then ionic strength is also going to be affect how many number of ionization is going to be takes place when it is dispersed into the dispersion medium. That part also we are going to discussing here. And then dielectric constant. Dielectric constant is also affect on the rate of the reaction. Then specific and general acid-base catalyst. If you have to add any catalyst into the reaction, then the reaction is whether it is occur in first step or whether the rate of reaction is going to be decreases. It is takes place due to the presence of catalyst, which is the presence of catalyst into the particular reaction. That part also we are going to observe here. Then some of the numerical problems which is related to the first order reaction, which is related to the second order reaction, that part also include here. And afterwards, the stabilizing medicinal agents against some common reactions, like we have to discuss here hydrolysis type of the reaction, then oxidation type of the reactions. And afterwards, the main important point from this chapter, it is the accelerated stability testing. How to determine the expiry date of the product and the different methods which is used for determination of expiry date of the product. It is possible to determine by using this method for determination of the expiry date of the product. Okay. Now, this is about the physical pharmaceutics second syllabus for the fourth sem. Yes, students. Yeah, is it clear now? What are the units which include in this physical pharmaceutics 2? There are total 5 units. Yes, students, there are total 5 units. First unit is a, yes, what is the first unit? Colloidal dispersion. Second one is the coarse dispersion. Then micromeritics. Yes, the first unit is the colloidal dispersion. Second unit, rheology and deformation of solid. Third unit is the colloidal coarse dispersion. The next one is the micromeritics, and last one is the drug stability. These are the units which include in this physical pharmaceutics 2. Yes, students, if you have any query related to this, please